Okay, welcome to DET tutorial. In this video, we'll be looking at this calculation from Graham's law of diffusion. And the question is, if 30 centimeter cube of oxygen diffuses through a porous pot in 7 seconds, how long will it take 60 centimeter cube of chlorine to diffuse through the same pot if the vapor density of oxygen and chlorine is 16 and 36 respectively? So for us to compare how long 60 centimeter cube of chlorine will diffuse through that pot, we will do that using the same volume as that of oxygen so that the comparison can be of the same volume. So from the question, since we are given that 30 centimeter cube of oxygen diffuse in 7 seconds, 60 centimeter cube of oxygen O2 will diffuse in 60 times 7 all over 30 seconds. So this 0 will cancel the 0, 3 here is 1, 3 here is 2. 2 times 7 is equal to 14 seconds. So if 30 centimeter cube of oxygen diffuse in 7 seconds, 60 centimeter cube of oxygen, it will diffuse in 60 times 7 over 30, which is equal to 14 seconds. So now we've gotten the time it will take 60 centimeter cube of oxygen to diffuse through the pot. And we're doing that because the question says, how long will it take 60 centimeter cube of chlorine to diffuse through the same pot? So we're looking for the time it will take 60 centimeter cube of oxygen because the comparison must be of the same volume. So from Graham's law of diffusion, we have that R1 square root of D1 is equal to R2 square root of D2. So since the parameters we are dealing with here is time and the vapor density, we will convert the R1 and the R2 to time. So like I've said before, that the rate of diffusion of a gas is equal to the inverse of time. So this is an important fact that we have discussed before. So if I replace this arrow with 1 all over t, my equation will now be equal to square root of d1 over t1 is equal to square root of d2 over t2. So my d1 will be my oxygen while my d2 will be my chlorine. So 2 will be my chlorine and 1 will be my oxygen. So from the question, the vapor density of oxygen is 16. If the vapor densities of oxygen and chlorine is 16 and 36 respectively means if they come in that order. So oxygen and chlorine 16 and 36. So the vapor density of oxygen is 16. So my D1 is equal to the square root of 16 over the time it will take 60 centimeter cube of oxygen to diffuse through the pot is what we've calculated here, 14 seconds. So my T1 is 14 seconds equal to my D2, which is the density for chlorine. The density for chlorine is 36. If the vapor densities of oxygen and chlorine is 16 and 36 respectively, so the density of chlorine is 36. So here I have my D2 to be 36 over T, which is the time it will take 60 centimeter cube of chlorine to diffuse through the pot. So having done this, what we cannot do from here is to cross multiply. So but before we cross multiply, 16 is a perfect square, also 36 is a perfect square. So what is the square root of 16? The square root of 16 is 4, so that will be 4 over 14 is equal to square root of 36 is 6 all over t. So from here we can now cross multiply. This t will multiply 4 and 14 will multiply 6. So my equation will now be equal to 4 times t is equal to 6 times 14. So 4 times t will give you 4t is equal to 6 times 14. So to make this t stand alone, we'll divide both sides by the coefficient of t, which is 4. So this will be 4t divided by 4 is equal to 6 times 14 divided by 4. So this 4 will cancel this 4 to make this t stand alone. So t will now be equal to 6 times 14 all over 4. So 2 here is 2, 2 here is 3, 2 here is 1, and 2 here is 7. So what I have remaining is equal to 3 times 7, and that is equal to 21. So the time it will take, so the question is, how long will it take 60 centimeter cube of chlorine to diffuse through the same port? So the time it will take 60 centimeter cube of chlorine is equal to 21 seconds. So this is our time.